at first, so I'd like to thank you for to invite me here. So I appreciate it from the bottom of my heart. Thank you very much. So today, I'd like to talk about the gas sensor. So, but this field is not so familiar to you. So I arranged my presentation only the essence of the semiconductor gas sensor. It's okay? So now it's not, so my computer is struggling. Okay, so the semiconductor gas sensor was found in the 1962. The next year, the sensors so accepted 50 years celebrated. So now, so the gas sensor widely used in the world. Typical gas sensor is to detect leak gases. So maybe you find such gas sensor in the kitchen. So that the gas sensor is very important. So in our use. In our life, but that gas sensor, so its application, a little bit changed. So in recent years, so because so now we pay attention to the environmental issue. So gas sensor target is changing to the so normal gas sensing to the very severe so gas sensing. For example, the VOC, NO2, CO2. So those very low concentration gases. Okay. Three kinds of gas sensor, but this kind so solid electrolyte gas sensor is very famous. So because many cars use so this kind of sensor as oxygen sensor. So maybe you can find the sensor at this point. So Japanese company produce this kind of sensor, and the company spreads this in the world except Tata. Okay. So now we can find many gas sensors in the house. So CO2 gas sensor, and so humidity sensor, and so other kind of gas sensor, odor sensor, and dew point sensor. Okay. And so the recent 10 years, so European companies use so special kind of sensor. It was old Napa system sensor. So maybe Asian countries also didn't use this kind of sensor because our car so includes the air conditioner system, but in Europe, so the outside is very clean compared with the Asian areas. So So they want to introduce the fresh air from outside. This sensor is very useful to control the hot temperature. That's the condition by this sensor. And so I summarize many kinds of gas sensors as a function of the gas concentration. So VOC is very severe the range because that's the concentrations in the ppb. Right? So gas leakage is very easy to detect. So in the case of the medical use, so many sensors was proposed, but there are many problems. So I think maybe the CO2 gas sensor is one of the candidates to use in the medical area, medical field. But the other gas sensor is on the way to the development. And also, the medical doctor requires many gas sensors. For example, methane, methanes, acetones, isoprene, and the sulfur containing the compound, and so on. But in medical gas sensor, there are many problems. So one big problem is the low gas concentration is quite low. Sometimes the doctor says the gas range is ppm, but so in the other case, so that the concentration down to sub ppb or the ppb and so on. So now so concentration, gas concentration detection, gas concentration is very severe for medical use. And the fast response and high selectivity also required. And the second problem is the portability. So the medical doctor wants to use the operating room or the hospital room and so on. So that system should be downsized. So for example, mobile phone. And so reliability is also required. Today, I focus on the 2 points. It's for high sensitivity and the selectivity and the portable size. Okay, I'm going to show the gas sensor, the principle mechanism. So the semiconductor gas sensor consists of the metal oxide powder. So we deposit that powder on aluminum substrate with gold electrode here. This film consists of this particle. So this is the ceramics particle. The oxygen molecule in air so adsorbed on this particle like this. The metal oxide is semiconductor material and operated at high temperature. The oxygen molecule adsorbed on the surface as O minus. So electron move to the oxygen. Finally, surface area that the resistivity is quickly high. So very high resistivity. When so in flammable gas, so approach the surface, so this gas is react with the adsorbed oxygen. Finally, that electron return back to the bulk. So surface resistivity quickly down. We can obtain the sensor signal shown here. So high resistivity in air. In flammable gas, the resistivity so quickly down, and so in flammable gas, the resistivity return back to the previous level. We can so detect the inflammable gas by using this sensing mechanism. Okay. To obtain the high performance sensor, so this the three important key factors needed. So I propose that this so three functions so 8 or 9 together both. Okay. The one is the receptor function. This is so we introduce receptor on that ceramic particle. So these particles to catch the gas molecule selectively. Okay. For example, we so loaded the copper oxide. This is the P-type semiconductor, and so this is tin dioxide. This is an N-type semiconductor. So the interface forms the P-N junction, but so these particles contact to the hydrogen sulfide. So this gas react with the copper oxide. So copper oxide changes to the copper sulfide. This is a semiconductor, but this is a metal. So PN junction to vanish and change to the metal semiconductor junction. Finally, so that the resistivity drastically changed like this. So this sensor materials can detect very low concentrations. Maybe it's 1 ppb. Okay. The second, so grain size control is very important, and the sensing film is used as a whole body. So that we that the sensing film needs the utility factor for it. The gas molecule must diffuse deep inside. Finally, this sensing film shows very high sensitivity. So I propose that high performance gas sensor by integrating the three factors. So the one nanoparticle so controls should be controlled. Doping, and this means so the semiconductor should be controlled in the donor density, and the nano-size receptor also contact this particle. Maybe it's the 10 or the 20 nanometer in diameter, and so this the particles agglomerate like a cluster, and then the cluster should be formed filled like this. So large size gas molecule can diffuse deep inside and reacts every part on every part. Finally, all of the particles that the resistivity change drastically. I'm going to show one example. So this is the VOC sensor. We prepared nanotube consisting of nanoparticle. Okay? This is very small particle, and this particle formed nanotube. And so we deposit this kind of nanotube on the aluminum substrate, and so we load the gold nanoparticle like this. So finally, this sensor can detect VOC in the sub-ppm level. So we prepared the nanotube on the TiO2 by using the hydrothermal treatment. Finally, so we can obtain the nanotube. Okay? So that's a nanotube that has a wall and so inside the space, the wall thickness is 8 nanometers. And this nanotube consisting of the nanoparticle like this. Okay? And so we deposited the nanotube on the aluminum substrate by so-called reading. So that the size was kept the constant value. And so we load the gold nanoparticle on the TiO2 nanotube. So this is the gold particle. So finally, this sensor shows a very good sensing property. So usually the nanoparticles of TiO2 didn't show the high sensitivity like this, but this nanotube shows a very high sensitivity. Maybe the sensitivity increased by 4 times. So we can modify the sensitivity and the selectivity. So by the control the receptor function and transducer function and the utility factor. Okay. So this sensor can detect the propofol also. The propofol is one of the medicine or the anesthesia. So this propofol was used by Michael Jackson before dying. And the propofol size is larger than the toluene. So usually, general semiconductor gas sensor couldn't detect this kind of gases because the molecular size is too large. Okay. So this sensor can detect the propofol like this. So maybe this sensor sensitive, more sensitive than toluene. And so the sensor system requires nano device. Now we developing the MEMS-type sensor. So MEMS-type, it is a very small size of the hot plate. This is electrode to measure the resistivity, and this is heating the heater. So this size is 100 micrometer. We deposit the sensing film like this. So this MEMS has very interesting advantages. So one is very quick response. second. So this quick response is very useful for the medical field. And so MEMS assisted gas sensors had very interesting properties for other application. One is battery drive device, and such a MEMS device can work for 5 years by using lithium-ion batteries. And so that MEMS chip can be introduced mobile phone and very small portable device. And so we can integrate MEMS devices in the portable system. Finally, this advantage, I think that this advantage is available for the medical field. Okay. I would like to conclude my presentation. For the semiconductor gas sensor in the medical field, we must give the solution from the 2 points. One is the sensor material should be optimized. And the second, small chip, like the MEMS chip, that is very useful for in the medical field. But base substrate that is changed to small size. We must arrange the sensor material because the contacting the system and the preparation system is quite different from the present system. So thank you for your kind attention.
Thank you for your presentation. Now we have some time for question and discussion.
You mentioned protocol detections using gas sensors. Have we done that experiment from real breath? I mean,